Welcome to AR Maths Pro Learning Academy. In this video, we are going to talk about Class 12 Mathematics, Chapter 1, Relations and Functions. Exercise 1.1, Explanation and Solutions, Part 3, from questions 11 to 16. Question 11. Show that the relation R in set A of points in a plane given by R equal P, Q. Distance of point P from the origin is same as the distance of the point Q from the origin. Is an equivalence relation. So in this question, we have to prove that the given relation R is an equivalence relation. At first, the given relation R is defined on set A, 2A. Where set A is the set of all points in a plane. There are a few points in a plane like this. This O stands for origin, and there are 2 points P and Q, which is at the same distance of OP to OQ. Both distances are the same as it is defined from the origin. Now, relation R equal PQ such that OP is equal OQ. This is the definition of the relation. At first, we are going to solve about reflexive relation. What is a reflexive relation? For any element A belongs to the set A, then A comma A belongs to the relation. This is the definition of the reflexive. For any P belongs to the set A, then P comma P belongs to R. Why? Because the distance of OP to distance of OQ are the same. So if I say OP is equal PQ, that means the same. That's why P comma P belongs to R. Therefore, given relation is reflexive. Symmetric. What is a symmetric relation? A symmetric relation is defined as if A comma B belongs to the relation R, then B comma A must be belongs to R. For if P comma Q belongs to R, then according to the definition, PO equal OQ. They are equal. The distance between PO and OQ are the same as it is defined. Now, if PO equal OQ, then OQ equal PO. They are the same, of course, which means Q comma P belongs to R. Therefore, the given relation is symmetric. Furthermore, we go for transitive. What is a transitive relation? A transitive relation defined as if A comma B belongs to R and B comma C belongs to R, then A comma C must be belongs to R. This is the definition of transitive. If P comma Q belongs to R and Q comma S belongs to R, then we have to prove that P comma S belongs to R. Now, according to the definition of the relation, P comma Q belongs to R, which means PO equal OQ. And Q comma S belongs to R, which means QO equal OS, according to the definition of the relation. If PO equal OQ and OQ equal OS, then obviously PO equal OS. This is equal this. Therefore, P comma S belongs to R. If P comma S belongs to R, that means the given relation is transitive. Now, we prove that the given relation is reflexive, symmetric, and transitive, which means the given relation is an equivalence relation. Now, furthermore, for the question, show that the set of all points related to point P, which is not the origin, is the circle passing through passing through P with origin as center, which means suppose I draw few points on the plane related to point P. Related to point P means all these points are at the same distance from the origin, which means if I'm saying if this point is the distance from this point to this point is k, so the distance from these 2 points is also k, because all these points are related to P. So all these are k, the distances are k, this distance is also k, so all distances are k. If all these distances are say, which means these points makes a circle. These points makes a circle. That is what we have to prove. So if O is the origin and OP equal K, I am saying, then the set of all points related to P is at a distance K from the origin. This is what we have done here. That means this makes a circle. Hence, this set of points forms a circle with the center as the origin O, and this circle passes through point P. Question 12. Show that the relation R defined in the set A of all triangles as R equal T1, T2, such that T1 is similar to T2 is equivalence relation. So in this question, there are two parts. The first part is we have to show that the given relation is equivalence. Relation R is defined on set A, and set A is set of all triangles. And it is defined as T1, T2, whereas such that T1 is similar to T2. Now, at first, we have to show reflexive, then symmetric, then transitive, which means it is an equivalence relation. Reflexive definition says for A belongs to A, then A comma A belongs to R. For any triangle T belongs to the set A, then T comma T belongs to R. Why these two triangles belongs to R? Because the same triangle is similar to the same triangle. Obviously, that means the given relation is reflexive. Symmetry. The definition of symmetry says if A comma B belongs to R, then B comma A must be belongs to R. If T1 comma T2 belongs to R, then according to the definition of the given relation, T1 is similar to T2. If T1 is similar to T2, which means T2 is also similar to T1. If T2 is similar to T1, that means T2 comma T1 belongs to R. So if T1 T2 belongs to R and T2 T1 belongs to R, that means the given relation R is symmetric. Transitive. The definition of the transitive says if A comma B belongs to R and B comma C belongs to R, then A comma C must be belongs to R. If T1 comma T2 belongs to R and T2 comma T3 belongs to R, as per the definition of the relation, if T1 T2 belongs to R, which means T1 is similar to T2, and if T2 T3 belongs to R, which means T2 is similar to T3. If T1 is similar to T2 and T2 is similar to T3, that means T1 is similar to T3. Since T1 is similar to T2, then T1 and T3 belongs to R, which means the given relation is transitive. Now we prove that the given relation is reflexive, symmetric, and transitive. So the given relation is an equivalence relation. Now, the second part. Consider the three right triangles T1, T2, and T3, which is here. So the sides of T1 is 3, 4, and 5. T2 is 5, 12, and 13. T3 is 6, 8, and 10. These are the sides. The question is, which triangles among T1, T2, T3 are related to each other? Now, based on side criteria, it is very clear that T1 and T3 are similar triangles because length of the ratios of the corresponding sides are the same. Check. 3/6 is 1/2. 2/8, sorry, 4/8 is 1/2. 5/10, which is 1/2. So T1 and T3 are the triangles which are similar to each other. Question 13. Show that the given relation R defined in set A of all polygons as R equal P1, P2, polygon 1 and polygon 2, such that P1 and P2 have same number of sides is an equivalence relation. So we have to prove that the given relation R is an equivalence relation. At first, given relation R is defined on set A, and set A equal set of all polygons. What is a polygon? A polygon is a closed figure with line segments. And here R defined as P1, P2, such that the number of sides of the first polygon must be equal the number of sides of the second polygon. Reflexive. A reflexive definition says for any element of set A, then A, A belongs to R. For any P belongs to A, for any polygon P which belongs to set A, then P, P belongs to R. Why am I saying they are belongs to P, P belongs to R? Since number of sides in polygon P is the same as number of sides in polygon P, because we are considering the same polygon, which means it has number of sides of that polygon must be equal. So the given relation is reflexive. Symmetric. The definition of the symmetric says if A, B belongs to R, then B, A must be belongs to R. If P1, P2 belongs to R, that means P1 equal P2. Number of sides of P1 equal number of sides of P2. The definition of the given relation. If number of sides of P1 equal P2, which means number of sides of P2 equal P1. Therefore, P2, P1 belongs to R. If P1, P2 belongs to R, then P2, P1 belongs to R. That means the given relation is symmetric. Third part, transitive. What is a transitive relation? A transitive relation says if A, B belongs to R and B, C belongs to R, then A, C must be belongs to R. If P1, P2 belongs to R and P2, P3 belongs to R, which means as per the definition, number of sides of P1 equal number of sides of P2 and number of sides of P2 equal number of sides of P3. If P1 equal P2 and P2 equal P3, that means number of sides of P1 equal number of sides of P3. Therefore, since P1 equal P3 and P1, P3 belongs to R. That is what we have to prove. Therefore, the given relation is transitive. Now, we prove that the given relation is reflexive, symmetric, and transitive. That means the given relation is an equivalence relation. Come to the second part. What is the set of all elements in A related to the right angle triangle T with sides 3, 4, and 5? Now, given right triangle has three sides. So according to this triangle, according to triangle T, how many sets are there which is related to T? Since this triangle has three sides, so this T must be related to any three-sided polygon. So three-sided polygons means set of all triangles, because three sides means triangles only. Set of all triangles in set A are related to the given right triangle, since T is a polygon with three sides. That's all. Question 14. Let L be the set of all lines in xy plane and R be the relation in L defined as R equal L1, L2 such that L1 is parallel to L2. This is the second part. So in the first part, we have to prove that the given relation is an equivalence relation. That is what we have to show that. In the second part, we need to find the number of all lines related to the given line. Now, at first, given relation set A has all lines in xy plane, and relation R is defined as, on set A, R equal L1, line 1 and line 2 such that line 1 must be parallel to line 2. This is the definition of the given relation. We have to show that this relation R is an equivalence relation. At first, reflexive. What is a reflexive relation? A reflexive relation says for any element of set A, then A comma A must be belongs to R. For any line L which is belongs to A, set A, then L comma L belongs to R. So line L is parallel to line L. Since the line L is parallel to line L, one line is parallel to itself in coordinate geometries, since their slopes are the same. So line L is parallel to the same line. So the given relation is reflexive. Now, symmetric. The definition of the symmetric says, if A comma B belongs to R, then B comma A must be belongs to R. If L1 comma L2 belongs to R, that means the definition says, the relation of the definition says, line 1 is parallel to line 2. If line 1 is parallel to line 2, that means line 2 is also parallel to line 1. Since line 2 is parallel to line 1, which means L2 comma L1 belongs to the relation. Symmetric says if L1, L2 belongs to R, then L2, L1 belongs to R, which means the given relation R is symmetric. Third part is transitive. The definition of the transitive says, if A comma B belongs to R and B comma C belongs to R, then A comma C must be belongs to the given relation. If L1 comma L2 belongs to R and L2 comma L3 belongs to R, as per the definition, if L1, L2 belongs to R, which means L1 is parallel to L2, and L2, L3 belongs to R, which means line 2 is parallel to line 3. This is the definition of the given relation. If you understand, L1 is parallel to L2 and L2 is parallel to L3, which means L1 is parallel to L3. If L1 and L2 are parallel, which means L1 comma L3 belongs to R. Since L1 L3 belongs to R, that means L1 L3 belongs to the given relation. That is what we have to prove in transitive. So the given relation is transitive. Now we proved the given relation is reflexive, symmetric, and transitive, which means the given relation is an equivalence relation. This is the first part of our question. The second part says, find the set of all lines related to the given line y equal 2x plus 4. The given line y equal 2x plus 4. Suppose I have a line y whose slope is 2. I have infinite lines which are parallel to this line y equal mx plus 2x plus 4 with different intercepts. Y equal 2x plus 3, y equal 2x plus 4, y equal 2x plus 5. I have infinitely many different real numbers. So the line parallel to the given line is in the form y equal 2x plus b, where b is any real number. So I have infinite lines. So my final answer is set of all lines related to the given line y equal to x plus 4 is y equal to x plus b, where b is any real number. Question 15. Let R be the relation in the set 1, 2, 3, 4 given by R equal this. Now we need to choose the correct answer from these options. At first, set A is given as 1, 2, 3, 4 and relation R defined on set A is R equal 1 is this one. We have to check one by one. At first, reflexive. The definition of the reflexive, we know it. For any element A belongs to A, then A comma A belongs to R, which means I must have all the ordered pair with the same elements. 1, 1, it is there. 2, 2 is there. 3, 3 is there. 4, 4 is there, which means the given relation R is reflexive. The second is symmetric. What is symmetric? The symmetric definition says if A comma B belongs to R, then B comma A must be belongs to R. I don't need to check the ordered pair with the same elements, which satisfies the symmetric. So this 4 I don't need to check. So 1, 2 is there, which means 2, 1 must be there. 1, 2 is there, 2, 1 must be there, which is not here. Check. If 1, 2 belongs to R, 2, 1 must be belongs to R. 1, 2 is here, but 2, 1 is not here, which means the given relation is not symmetric. The third one is transitive. The definition of the transitive says if AB belongs to R and BC belongs to R, then AC must be belongs to R. In transitive, I don't need to check ordered pair with the same elements, which means 2, 2, I don't need to check 1, 1, 4, 4, and 3, 3. So I will check this one. 1, 2 is there and 2, 2 is there. 1, 2 is there and 2, 2 is there. 1, 2 belongs to R and 2, 2 belongs to R, which means 1, 2, again 1, 2 must be belongs to R. Yes, it is 1, 2 belongs to R. So this is a transitive. This ordered pair with the same elements, I don't need to check. Now 1, 3 is there and 3, 3 is there, which means 1, 3 must be there. It is here, 1, 3. And there is another one. 1, 3 is there and 3, 2 is there, which means 1, 2 must be there. 1, 2 is there. Yes. So this is also satisfies transitive condition. 3, 3, I don't need to check, it is a transitive. 3, 2 is there. 3, 2 is there. And 2, 2 is there, which means 3, 2 again, which is also here. I checked all the conditions. So I have checked similarly. We have to check like this, all the ordered pair, which means the given relation is transitive. So the given relation is reflexive and transitive, but not symmetric. So the answer is option B. Question 16. Let R be the relation in set N given by R equal AB such that A equal B minus 2 and B must be greater than 6. Choose the correct answer. At first, I'm going to delete option A. Since B must be greater than 6. So here B is 4, which is less than 6. So option A is not my answer. Now, the difference between A and B must be 2. Check. The difference between A and B must be 2. Check A equal B minus 2. So whatever you have the value of B, which must be less than 2A. So 3 and 8, the difference between 3 and 8 is 5. So it is not, this is not my answer. 6 and 8, yes, this is possible. And 8 and 7 is not possible. So it is clearly observed that option C is our answer, but let us prove it. Option C satisfies the given condition. Let us see. These are the two given conditions. B must be greater than 6. Yes, B is greater than 6, which is 8. If I plug in this 8 in this B, 8 minus 2, which means A is 6. A is 6. So the answer is option C. This is the end of the exercise 1.1 of chapter Relations and Functions. If you have learned something new today, hit the like button, share it with your friends, families, and don't forget to subscribe. Drop your thoughts in our comment box. Thank you.